This video will cover section 4.7, inverse trigonometric functions.
So yeah, inverse trigonometric function. All right. Now, before we look into the graph or the definition of the inverse trigonometric function, we're going to review quickly the sine graph. All right. And so you know that from 0 to 2 pi, we have one period, right? Or one full cycle. Now, similarly, if we look on the left side from here, and it will have to go all the way to 2 pi for us to be able to say that's another cycle. So, and right here, you can see the beginning of a new cycle, right? And if we want to finish it, we'll have to go something like that. All right. Now, if we do a horizontal, if we trace a horizontal line test on this graph, it's not going to pass it, obviously, because it's going to touch multiple points, right? And then since this graph, it keeps going in both directions, we could say it will touch an infinite amount of points. What is the horizontal line test is testing for?
1, 2. Well, yeah, 1 to 1.
Okay, so a lot of you, 1 to 1 to see it's a 1 to 1, right? So would you say that a sine function is a 1 to 1 function? No. So not a 1 to 1. Okay, so if we were to get the inverse of the sine function, then the inverse is not going to be a function. It will only be a relation, all right? So what we have to do here is we're going to restrict the domain so that our graph can pass the horizontal line test. And so the way we're going to restrict the domain is going to be from here to here. So in other words, we're only going to take this part of the graph, what I'm tracing in blue. And so if we were to trace that horizontal or perform the horizontal line test on that chunk of the graph, would it pass the horizontal line test?
Yes.
Yes. It only touches 1 point. So now that image of the restricted piece of the graph, the restricted domain that we're using, is the same graph that you see here, right? And so we're saying that the domain is going to be the interval from negative pi over 2 to positive pi over 2. Or in other words, any x value that will be greater than or equal to negative pi over 2, but less or equal to pi over 2. So looking at the number line, if this was 0, this will be negative pi over 2, and this will be positive pi over 2. So we're going to be taking numbers that come from here to here, and everything in between, of course, including the pi over 2 and the negative pi over 2. Now, going back to inverse functions, this one is still the original sine function, all right? Just with the restricted domain. Now, going back to this one, let's say, what will the range be for this function? The y values, what is the smallest y value that we can have? Negative 1, and the greatest? Positive 1. All right, so I want you to keep that in mind. Now, we have here that we already talked about how the domain of the original sine function, we were going to restrict it to that. So when we talk about the inverse function, it makes sense to say that what used to be the domain for sine is going to be the range for the inverse function, which is read, we're going to read it as sine inverse. And so whatever used to be the range for the original sine function now is going to be the domain for the sine inverse function. So we are interchanging the domain and the range, or we're interchanging the x and y. What else can I tell you? Let's look at this statement here, and it's very important because this is the notation for sine inverse. It is not the same. You cannot think of it as an exponent. It's not the same as this expression because 1 over sine of x is equal to what? The reciprocal identity. So what is that other identity? Trigonometric. Which one?
Cosecant.
Cosecant. So that one, when you have 1 over sine, that means cosecant of the same angle, which is x. So if you notice, this is totally different. Okay? This is sine inverse. And this is the reciprocal of sine, which happens to be cosecant. Okay, now let's look at the graphs. So you guys get the idea how our domain and range will be interchanged, right? Let's look at the graphs now of both. So this is the same graph that we started with, the restricted piece of that sine graph. And I want you to keep an eye on these points that I'm about to circle. So here and here. And so we have pi over 2 comma 1 and negative pi over 2 comma negative 1. We have the domain and range like I already explained to you guys here. And now if we were to reflect those points across this line, how do we call this line here? Y equals x, right? It's right there. And what's the name of that function?
Identity.
Okay. So identity function. So inverse functions they are reflected across that line. Don't forget that. Just like exponential and logarithmic. So if we take those points from the original sine function and we interchange x and y like here, so do you guys notice now we have 1 comma pi over 2. And so we plot that point there. Now we do the same thing with this point. We reflect it across the line y equals x. And so we will come up, remember, that is done just by switching x and y. We don't change the sign at all. So that will result in this point. And so that point will give you the inverse function, the sine inverse function. And you could see it here. So this right here is already the inverse, all right? This graph in the middle, you can see both together. And the third graph, the one on the right side, that is the sine inverse. So you could see again how the domain of sine inverse used to be the range of sine, and how the range of sine inverse used to be the domain of sine. Okay. Now, we did a problem that was a little similar to this one, and it was a word problem where we had to find, I believe there was a building, angle of depression, and then we had to find something. And we did this with the calculator, so now we're going to do it without. Oh yes, I forgot to mention this. Your exam is going to take place on Tuesday. Because of your face. You're like, as soon as I say exam, it was like, okay. Don't be scared. What else? Review. Since oh yes, and a quiz. The quiz is going to happen on Thursday. The quiz is going to be of the unit circle.
This Thursday? So we just have to fill in like.
Correct. So I'm going to give you a blank. Leslie, are you writing this down? Okay.
Do you want us to color code?
No.
No, it's okay. Haru should.
Oh.
No, I'm just kidding. I'm gonna give you a blank template of the unit circle, and then you guys will fill it in 5 minutes.
What?
5 minutes?
Easy. Just remember, like, it's like
Yeah, you memorized it.
2.
I haven't memorized,
I mean, I know
I
like
can't
I
write that.
don't know like this.
Okay, I'll give you guys 10.
Okay.
So you could time yourself. I'm gonna post one on Edmodo in case you want to print it for practice. Yeah?
Yeah.
Would you guys like that? Yes.
If we finish all the homework, are we still supposed to go to the lab
Yes.
and do what?
Nothing. You just wait there for an hour and then you come.
Wait, Miss
Or
Burke.
how about if we?
So why do we care about the sine inverse function? So what we're gonna do with the sine inverse function is we're gonna do the opposite of what the sine function does. So what does the sine function will do for us? So in this case, for the sine function, we have an input that will be an angle, right? And then the output is the trigonometric ratio. And we know that they go from -1 to +1, and then all the values in between. So it makes sense. We have 0 in the middle, we have -1/2, we have +1/2, and so on. Now, with the sine inverse function, sorry, I'm doing this wrong. The input will be the trigonometric ratio, and the output is going to be the angle. So let me tell you how this works. So if I ask you, what is the sine inverse of 1/2? So I'm looking at this trigonometric ratio. So what is the angle that corresponds to 1/2? Pi/6. So that is the answer. Okay? So that is why I need you to memorize that unit circle so that you can answer questions like that. Okay? Now, the reason that, remember how we started by restricting the domain of the sine function from -π/2 to π/2? So our answer can only be given in these terms. They need to be angles between that -π/2 and π/2. Okay, so you can look at this table. I'm going to ask you a few questions. So, Bastian, what is the sine inverse of -√2/2? Okay. Andrea, what is the sine inverse of the square root of 3/2?
pi/3.
Very good. Lorenzo, what is the sine inverse of -1? Mm-hmm. Okay. Ezekiel, what is the sine inverse of -√3/2?
The square root of 3/2 would be pi -5/3.
Okay. Biryani, what is the sine inverse of 0?
0.
And Genesis, what is the sine inverse of -1/2?
-pi/. Oh, wait. 1/2, right? -pi/2.
Okay, very good. All right, so this is pretty easy because you're looking at the table, right? But it's not that hard without looking at the table, don't worry. So let's go to the next slide to answer those questions. And so I want you to remember one thing. The fact that we're restricting the domain, and I know I keep going over and over that, okay? But I promise you I have a point. It is very important. So I want you to keep this, if we look at the unit circle, we're taking numbers that are greater than pi/2, starting from 0. So like that, right? In the positive direction. But we're also taking angles that are negative. So we're going in the negative direction, right here. And this will be -pi/2 if we go in the negative direction. So I want you to keep this image in your head, okay? We're going to keep using it. Right, that one, right there. All right, so going back to this question, I already told you, we're going to go from here to here. This is pi/2. Or from here to here, and this will be -pi/2. Should we include those two angles?
Yes.
Yes, we should. Okay, so now we got to find the angle for which the sine inverse is equal. I'm sorry, for which the sine is the square root of 2/2. So will that be in quadrant 1 or quadrant 4? It has to be quadrant 1, right? Because it will be the sine is positive in quadrant 1. And so that's a very famous angle. I think we all know which one is that. What would that be? Where the sine and cosine are the same? Pi/4. Very good. Okay, let's do the next one. So sine inverse of the square root of 3/2. Now, are we talking about the first quadrant or the fourth quadrant? the first. So now, will that be here or here? Would it be above or below our point? Above, right here. And so that angle, do you guys know what's the angle that corresponds to that? Pi over 3. And if you're not sure, you can look at your table that is on the slide before. All right? Okay, so I want you guys to work on example 2, both of them, and keep in mind they're negative angles, so you're going to be working in which quadrant? So think about it if you want to consult with your partner.
On the exam, you're not going to ask us to fill in the unit circle.
Well, you know what? I'm not going to ask you, but my students actually do that. As soon as I get the exam, they work. Yeah. So I might put a blank on there. So remember, your answer can only be inside this interval. From there to there, but it has to be negative. Okay. So we're talking about negative 1/2. That actually happens right here, right? Okay. So Jose, what do you got?
Negative pi over 6.
Very good. Negative pi over 6. So that's like a little number, maybe right here, right? Negative pi over 6. You guys can see it's in the interval. And then for the next one, Yaren, what do you got? Negative pi over 4. Very good. So that one will be here. I know it's not exact. Negative pi over 4, which actually happens to be right here. So yes, it is between that interval. Okay, so isn't it this easy, guys? Let me tell you guys, want to know how it becomes easier? When you memorize all the trigonometric ratios. Yes, it's a lot easier. Okay, so next, so this is why I insist, I will not let you use the unit circle. You have to memorize it. All right, next, let's look at the cosine graph. So again, same story. You already know it is. It keeps repeating, right? The wave, and you can see them on the wall, right? By the way, who did that graph? That was second period, right? Second period, you need to come to my classroom and draw the y-axis, please. So in this case, we already know if we trace that horizontal line, it's not going to pass the horizontal line test, which means that the cosine function is not a 1-to-1. Okay, sometimes 1-to-1 in books, you might see it written this way, like a ratio, okay, 1-to-1. So again, we have to restrict the domain, and so what we're going to use for this one is going to be this part of the graph. Okay, so from 0 radians to pi radians.
So we use like another one.
You know what, Tina? I've never thought of it. Like, I've never actually asked a teacher that. I will say, technically, yes. You should be able to use any, right? But there are other things besides this that are already based on the definition that you use that. So I wonder if there will be any issues. You know what I mean? But if I see one of my professors, I'll ask them. All right, so we take that, and then so here's the piece of the graph from 0. So the cosine of 0 is 1. The cosine of pi is -1, right? You guys remember that? So now if we look at the unit circle, what I'm taking is from 0 degrees to pi. Should I include pi?
Yes.
Yes. So now we're going to be working with quadrants 1 and 2. All right? In quadrant 1, the cosine is positive or negative? Positive because the x's are positive. And in quadrant 2, the cosine is negative. All right, awesome. So here we have the notation for it. And again, we read it inverse cosine function. So let's look at domain and range. And so, of course, let me compare the two graphs here. So if we have this point at 0, 1, if we interchange x and y, we will come up with this point down here, which is 1, 0. You can see it on your slide. Similarly, if we have a point at pi negative 1, and we interchange the x and y, we will come up with this point here, which is negative 1, pi. And so that is the graph of the inverse function. Same story, the domain and the range are going to be interchanged. So for the restricted cosine, the domain is from 0 to pi. What will be the range, guys? What's the smallest y value here?
From negative 1 to 1.
Yes. Okay. So when we talk about the other one, the cosine inverse, the domain and range will be also interchange or switch. So the domain will be from negative 1 to 1, and the range will be from 0 to pi. And that's what you could see here. All right, so I'm going to ask you guys some questions now. Now remember, this will be the input, and this is the output, the angle, when we talk about cosine inverse. All right, so let's see. Raquel, what is the cosine inverse of negative 1? Very good. Andrea, did I ask you one already? No? Yes? Crystal, cosine inverse of 1/2. Very good. Leslie, cosine inverse of negative square root of 2 over 2. Very good. Sean, cosine inverse of the square root of 3 over 2.
5 or 6.
Okay. Dima, cosine inverse of the square root of 2 over 2.
5 over 4.
Good. And Gabriel, cosine inverse of 0.
5 over 2.
Very good. And let's see. Lorenzo, did I ask you one already? Are you sure? Okay. Bastian, did I ask you one? Oleg?
No.
Okay, Oleg. What is the cosine of pi over 2?
Cosine inverse.
Yes, 0. So I didn't ask him cosine inverse. I asked him cosine. Okay? Yes, I was trying to trick him. All right, now let's answer those questions. So remember that image, that little picture, we're taken from 0 to pi. So our answer can only be given in this little interval from 0 to pi. And of course, everything in between. All right, so we have here the cosine inverse of negative square root of 3 over 2. First of all, where is the cosine negative? In quadrant 1 or 2? 2. So I know that it's not the one that goes there, right? We know that. Because that would be 45 degrees or pi over 4. And what is the cosine it there? Square root 2 over 2, except negative.
So it's like after.
Would it be above or below? Oh, but let me ask you better. Would it be to the left or to the right of that line?
To the left.
Well, think of this. If I pick this one, that will be actually, oh, but we're talking about the x. We're talking about the x. We're talking about cosine. So yes, it is going to be right there.
Mostly.
I'm thinking.
Oh.
I just hold my face. Can you guys look at your table just to make sure? Cosine inverse of the negative square root of 3 over 2?
It's
Five,
5
5 over 6.
So it's right here, right? Okay. Let me ask you guys something. It's kind of like a little review for the test. What is the reference angle of 5 pi over 6? Do you guys remember that? Pi over 6. Could you tell everyone what is a reference angle, Farouk?
30 degrees.
I don't know, explain it. It's like the angle between
The terminal side and
the x-axis.
the x-axis. Very good. All right. Next question here. What is the cosine inverse of negative 1/2? Will that be in quadrant 1 or 2? 2. That's going to be there. If you don't remember what angle it's at, this will be 0, and if I count in thirds, if I divide the pi in 3 pieces, this will be pi over 3. And 2 pi over 3. So the answer is 2 pi over 3. So yes, that's why it's important to have that unit circle memorized. Now, are those two answers in between this range? Are they? Yes. 2 pi over 3 is here, and 5 pi over 6 is like somewhere here. Okay? Pretty easy. Let's go to the next one. Now we have tangent, and it's not a secret that tangent function is not a one-to-one, right? We could touch how many points? Infinitely many, right? And of course we only see 4, but we know that this graph keeps going. We do have arrows in both directions. So the restriction, it just kind of makes sense that they center their restriction, and they chose to use this part right here. So if you guys notice, we're using angles that are between negative pi over 2 and pi over 2. So almost the same as sine and sine inverse, right? What is the difference? Okay, so when we restricted sine, we said x has to be from negative pi over 2 to pi over 2. And then we're restricting tangent like that. What's the difference?
It's not included.
Yeah, it cannot be those
Why not, Sean?
because there's no line.
Well, I see some dash lines. What do they call? What are they called?
Vertical.
Vertical asymptotes. Yes. So it's not continuous. I hear a lot of things. It's not continuous. It can. There's a vertical asymptote. So yes, because actually the tangent at those particular values will be undefined. All right. So that's why we do not include those. Very good. Now the reference points, I'm going to just show you the image of the tangent inverse. And so we're going to use the same idea. We start with a reference point such as pi over 4 comma 1, because the tangent of pi over 4 is 1, right, Sean?
Yes.
Okay. And so the tangent of negative pi over 4 is negative 1. So if we just interchange those x and y values, like you can see here, you get those 2 points. You just switch the x for the y and vice versa. Okay, now similarly, domain and range for tangent will be interchanged for tangent inverse. And that is the image of that one. Let me see if I can draw both on the same xy axis. Something like that. I always have trouble drawing that. Okay, so it will be something like that. They are reflected across this very famous line. How do we call this line? The what? What? Identity function. All right. So let's go ahead and get to the questions. And yeah, you guys get the idea, right? We restrict tangent. So then because of that, tangent inverse, this will be the range, and this will be the domain. All right, so we have here a table. Samantha, what is the tangent inverse of the square root of 3? Very good. Michelle, tangent inverse of 1. Okay. Emily, tangent inverse of -1. Yes. Adelina, tangent inverse of the negative square root of 3. Okay. Alexis, tangent of -1. Okay. And where's Miguel? He's on what? On vacation? Wow. Please tell me not in Vegas.
No, it's Houston.
Okay. All right. I won't be jealous. Okay. Tangent inverse. Who else? That's it. I already asked you, right? Emily, did I ask you? Alexis? Raquel? Gabriel? Adelina? Everyone answer a question now?
No.
Corina? Okay, Corina, what is the tangent of? It's going to try to trick you. The tangent of 0? 0. Okay. All right. That was. Can I trick one of you guys?
No.
Okay. Yes. Let me try.
I'm trying.
All right. Right here. Peru.
Yeah.
I was gonna pick on Miguel, but he's not here. Peru. What is the cosine inverse of 2? Anyone can answer.
It's 0.
No.
It's 1.
No.
Okay, I'm not gonna guess.
Undefined?
It's undefined. Okay? Look at the cosine graph. Well, that one does not have a y-axis, so can't show you there. But look at the cosine graph. It only goes from -1 to +1. So anything that goes above or beyond that, above or below, will be undefined. Okay?
That's just me.
All right, Miguel. So
Oh.
you missed on an opportunity.
You called Peru.
No, I'm talking to Miguel on the video.
Okay.
Okay.
Sure, miss.
Talking to future Miguel, unless he does.
All right. So tangent inverse. Let's not talk about that, please, because when students die, I get very sad.
He's not.
Okay. The tangent inverse of the square root of 3. Pi over 3. Thank you. All right. And tangent inverse of -1.
Negative pi over 4.
Negative pi over 4. All right. Now for tangent, I want you to keep this little image in your head, okay? So we're saying that we're taking from -pi over 2 to pi over 2, right? Of course, in the positive and negative direction, but we do not include those, so I'm going to draw an open circle. So let's go to the next slide, guys. Okay, we have all 3 here. And so I'm just going to make some little drawings here for you to use as reference. When we're talking about sine inverse, your values must be here. From -pi over 2 to pi over 2, including those, right?
So,
Yeah?
what about like secant, cosecant, cosine?
Yeah.
We will also get to, well, okay. We could use them, but they're not very common. Now, on your calculator, yes, they are there. And we could use them even with the triangle. And for restricting the values, I'm thinking. I'll tell you after the break. Because I am not sure if we restrict the same as sine, and I don't want to tell you a lie. I'll rather check. Okay? Like for cosecant inverse. So I'll check. All right, now for cosine, we're going to use from here to here, from 0 to pi. And for tangent, we're going to use from negative pi over 2 to positive pi over 2, but without including, so we need open circles there. So these are the three most commonly used: sine inverse, cosine inverse, tangent inverse. And I'll check on that during the break. Okay, so do you guys want to take your break now?
Yes. Well, actually, yeah.
Yeah, like 5 minutes?
It's like there's 10 of them.
So we only have those 2 slides left. We could finish them, so let's take 5 minutes.
Miss, can you go back over because I forgot the
Yes. Let's move on to example number 5, and now you guys will need to use your calculator to find the value of the sine inverse or the tangent inverse of those values. So for the first one, I would like for you to go to your calculator, and you have a button that is to the left side of number 7 that says trig, stands for trigonometric functions. And then, as you can see, you have cosecant inverse and secant inverse as well, right? And cosecant inverse. So go ahead and type in sine inverse and then 1/4.
How many decimal places?
Let's keep 4.
Okay.
0.2526.
27.
Miss, what was this on? It was on that. It was like 4 point something.
4 point something.
Yeah, it was like
8.
before though. This.
Oh, the slide.
No, for like online Pearson. I was doing homework and it had this in it.
Oh, yes. 4.2.
Yeah.
Okay, did anyone get a different number?
No.
Don't be afraid if you did. It's okay. No one?
I got
Come on.
14.477.
14 point. What else?
4775.
4775. Okay, so who's right?
Me.
The
First one.
No,
The
both.
second?
Both are correct. That's in degrees.
How did you do it?
And this one is in radians.
Because mine's not set on a rating.
Okay, and that is degrees. Now, if you want to know how to switch, you might want to try it. You go to menu, go the home screen, and then you press I'm sorry, let me see or something. Settings, and then I think it's handheld settings or setup, and then you change from degrees to radians, and then make sure you press make default at the bottom.
Wait, no, I don't think so.
No, it's not. So settings,
Go to document. Settings.
document settings.
You want me to do it?
See, so you can learn.
Yes, I am.
I usually make default.
So do we leave it as degrees or ratings?
Whichever you want. Now, I'm going to suggest this. When you're doing your homework on my math lab, make sure you read those little tiny letters that will say if you're answering degrees, if you're answering radians.
Why is it like opposite? Like if it is degrees and then
Here we use more radians, right? And physics you use more degrees. I'm not sure. I'm really not sure. Radians is like more exact, like especially if you use pi. For example, in calculus, you do a lot of things with pi. Have I talked about pi day?
Yeah.
Yeah.
So that's how you guys got approved
March 14th.
by the speaker?
Are we gonna get pi, Miss?
Multitasker.
Are we gonna get
We're
pi?
both multitaskers here. Wow. Okay, so yes, Pi Day got approved. We need to start planning because you guys are all going to be in charge of it.
We're gonna get
And
pi?
now that's going to involve some serious extra credit.
Are we gonna get pi?
Right, what do you do? Pills now? We'll come
Oh.
back. Do you want us to do
I need to think. I need to like
Pi
brainstorm
slash
and we should probably get together. Are you like the cake police?
I'm the pi police.
Calm down.
Get
Calm
it
down.
right.
I'm going to contact Village Inn. Village Inn, if you're listening
Key line
to our
pi.
video. I'm going to see if we can get some donations.
So what's the, we gotta get the most pies?
No.
No, that's not what that is.
Are we gonna do pie in the face, Miss?
Yes.
Really?
You are going to be the...
You too, Miss. You
the
too.
dummy.
The teacher has to be in it, Miss. Has to be.
All right, guys, I want you to do that one where you're talking on your calculator, please. Yes,
What is it?
March 14th.
This is for my low grade.
We will have pie walk, like cakewalk from pie. So we're gonna have the whole day pie on the whole day is gonna be pie.
Revolving house.
But
In
if
all
you have
classes,
to study, you're
that's
gonna have
all.
to
Like,
be
they gotta
those
prove.
things.
Oh,
You know, pie has all those stitches.
Okay, it happens to be the Monday after Thanksgiving, when we're all still in vacation mode.
Thanksgiving?
I mean, I'm sorry, spring
I was like,
break.
next year, what?
Spring break, right after spring break, the Monday, and so the speaker approved it.
So what's going to be the dumbest in every?
It's gonna be like, no,
Oh.
it's gonna be like our nerdy carnival.
And does everyone go to Christmas?
Everyone, the whole school. But you guys are gonna be in charge, the pre-cal students. That's how I wrote down the.
But tell them what the links are, because they think it's just funny.
They will understand.
But it sounds
I
like
go
something.
It is funny.
Okay, we'll have a meeting to discuss that, okay? All right, do we have an answer for this, guys?
Yes.
Yes.
Negative
Negative
84.
1.4675.
Negative,
1.4675.
Negative 84.
okay, and the other one? I know someone did it in degrees.
Negative 84.037. 0,
Negative 84?
84, 0837.
84 what?
0837.
0.0837?
0837.
Okay, got it. And that's in degrees. And do you guys remember how to convert from one to the other? You know, that might be on the test.
Pi over 180 something like that for one.
Okay, so if I was to go from radians to degrees, what would I multiply that by?
It's pi over 180.
So since I want to have degrees, I don't want to have pi on top, so the pi will go on the bottom.
It's not 1.
Make sure you guys review that, okay? That will be on the test for sure. I'm gonna go ahead and upload a practice test for you so that if you run out of things to do in lab, you can work on that. Right here we have inverse properties summary. And so you already know that inverse operations undo each other, right? Yeah?
Yep.
And so it's super convenient because we can just cross things out like that, right? So, however, you can't do that all the time. The only time you do that is if the number here is in between that interval, this number. And we could only do it this way if the angle here is in between that interval. So if not, that's not the case, we cannot just cross out and we have to rely on other method, but it's pretty easy. Same thing applies for cosine and tangent. We have to make sure that we're within the valid intervals, all right? Okay, so let's answer those last problems. And we have here something like cosine inverse. So let's figure out if we could just cancel it out. So for cosine, we restrict it this way, right? From 0 to pi. 0.6, that tells me is radians because I don't have the degree symbol. What is pi approximately to?
141.9265.
Okay. So will 0.6 be in between that interval, guys?
Yes.
Yes. So can we cancel out?
Yes.
Yes. So the answer is 0.6, and that's it. Now right here, for sine inverse, we restrict it in this way. From negative pi over 2 to pi over 2. It's 3 pi over 2 in between that interval.
Yes.
No. Remember, we're looking from,
But isn't 3 pi over
No,
the
3
same thing
pi-
as negative pi?
it's
over
That's
2?
past.
well,
Yeah.
I know that if we were in the positive direction, then yes, it will be there, right? But still we cannot just cancel. So instead of that, we're going to answer it from inside out, okay? And this is what I mean. So what is the sine at 3 pi over 2 right here? The y value will be right here. Follow the red angle. What is the y value at that point? -1. And now, what is the sine inverse of -1? Right here. So that will be -pi/2. Okay, now, how about this one, guys? Can we just cancel? What do you guys think?
Yeah.
Yes.
How do you know if we can cancel again?
Actually, oh,
No.
interesting.
Oh, yeah.
Interesting. Type on your calculator cosine inverse of 1.5. I'll tell you in a minute how you know where you can cancel.
We put cosine inverse.
Of 1.5.
Undefined.
Undefined. And so I'm going to back up a little bit because I made a mistake here. What we should have looked at here is not if 0.6 is between 0 and pi, but to see if it's between -1 and 1. That's
Yeah.
what we should have looked at. My bad. So now when we look at this one, it needs to go from -1 to 1, so there's no angle that will have a cosine of 1.5. That's why you get undefined on your calculator. And so that will be the answer here. We don't cross out, we just say undefined, because the inside does not have an answer. All right. The last three problems, they have, we have to draw something on them. And so, well, going back to how do you know if you can cancel? Let me show you quickly. So you can only cancel if the question has sine inverse in between, inside, that x needs to be between -1 and 1. That's the only way you can cancel that. Yes.
Oh, okay.
But now, if you have sine inside, then the x needs to be between -pi/2 and +pi/2.
Okay,
Right?
yeah, I was just going.
And then same thing for this one, the x will have to be between -1 and 1. Okay? All right, let's go back to the last problem. So problem 7. Problem 7, we have tangent inverse, and then we have that 5/12. That's all we have. We don't know anything else. So what we can do is just draw it. So do you guys remember tangent inverse was in which quadrants? 1 and 4. So, oh, I'm sorry, and we need open circle, right? So where's the tangent positive? In quadrant 1 or 4? 1. So what that means is that I'm going to have some type of angle here in quadrant 1 where the tangent is 5/12, and tangent is defined as y/x. So that means that for my y, I will go 5 units. 1, 2, 3, 4, 5. And for my x, 12 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I will have a point here. And I'm going to connect it with the origin. And so at that point, I have 5, 12. So that tells me that if I draw a triangle, like you guys did with your unit circle, the vertical distance is 12, the horizontal distance is, no, the other way. The horizontal distance is 12, so the point is wrong.
Yeah.
Sorry. So the point should be 12, 5. So the horizontal distance is 12, the vertical distance is 5, and to find the hypotenuse, that's not an issue, right? We can find that one pretty easy, and that will be the square root of 12 squared plus 5 squared. So that will be the square root of 144 plus 25, which will give me the square root of 169, which is equal to 13. So the hypotenuse is 13. Okay, now let's go back to the problem. Now, Lorenzo, pick a letter, a Greek letter, okay, to name our angle.
Beta.
Beta?
Beta.
Beta. That one? Okay. So, this question here, like I said, we're going to answer it from the inside out. What is the tangent of the tangent inverse of 5 over 12? The answer is really hard to find. It's just theta. Right here. That's it. Now, can we answer what is the cosine of theta? Theta is adjacent over hypotenuse. So that will be 12 over 13. Okay. The hardest part here is to get the drawing right, to get it in the right quadrant. Let's do the next one. We have sine being negative. Where is sine negative, guys? 4 and 3, or 3 and 4. However, sine inverse was defined like this, right? So what are the quadrants that we can use? 4. Only 4. So I'm going to position my angle here, and sine is defined as y over hypotenuse, or r for radius. And so if I'm saying the y is -1, that would be here. And then that one is 3. Something like that. Okay. And we drew a triangle. We have the vertical distance is -1, hypotenuse is 3. Could we find this one here? Yes, yes, we can. And so that will be, let's call it A. So A will be the square root of the hypotenuse square minus this one square. What, Sean?
Isn't the 3 on the top?
No, the 3 will be the hypotenuse. So with this one, we had tangent, so it was y over x. But with this one, it's sine inverse, so that's why it's r, the hypotenuse. If it was cosine, then it would have been the x and the hypotenuse. Okay, so this one, we do 9 minus 1. And so that will be the square root of 8. And you already know that with the square root of 8, we have to factor it. So we have 2. 1 is a perfect square, so that will be the square root of 4 times 2, which is equal to the square root of 4 is 2, and then the other 2 stays inside. So that's the number that I need here. Okay. Okay. Then pick a letter for the angle. M. Okay. Now to answer the question, the cotangent of here, what is the sine inverse of -1/3? Well, the angle that Yaren chose to name M.
So in my math lab, do we like look up the letter?
You will just give the final unless they have it by parts.
Oh, okay.
If they already have a drawing for you, make sure you use the letter of the angle.
Oh, okay.
Okay? And so what is the cotangent? Cotangent is defined as hypotenuse over, no. X over y. Right? Because tangent is y over x. Cotangent is the reciprocal. So x over y. You should know all this for the test, right? If you're still thinking, if you're like, what is she talking about? Then you're in serious problem. So x over y, the x is 3, no, the 2 square root of 2. And the y is, what's the y?
1.
-1. So this should be -2 square root of 2. That's the final answer. Okay, and the very last one, I promise you I can get it done in 30 seconds. No kidding.
Every time you go.
You're gonna time me?
No, hold on. Wait.
Okay, fine. So, sorry I didn't let you go early.
You sound rude.
Okay, so sine inverse. Okay, so sine it is. What is sine? Y over R, right? So right here they're telling us that x, the sine inverse is x over 1. So that means that the x is representing the opposite side and the 1 is the hypotenuse. So this is my angle. I'm going to call it beta. So my opposite side will be x, just like here. And my hypotenuse will be 1. Can I find the adjacent angle? Yes. I'm going to call it A. And that will be the square root of the hypotenuse square minus the side square. So A is equal to the square root of 1 minus x squared. That is, I know it might not make much sense to you, but that's what we will call that side. Now to answer this question, it will be, what is the cosine of the sine inverse of x? And so the answer here will be the angle beta. And now what is the cosine of beta? Cosine is adjacent over hypotenuse. So start packing. So the adjacent is the square root of 1 minus x squared, and the hypotenuse is 1. So the final answer will just be the square root of 1 minus the x squared. Okay, we're done. So now you can pack.